Hey there, Floppers, and welcome back to our quest to finish every single video game. That's right, absolutely awesome. Today we're back with more A equals B, and we're gonna be doing 2-7 Ascent. So if you didn't watch the first video, maybe you should go back and watch it. But if you don't wanna or you don't remember, the game basically operates in a way where you have a program that is simple in its string replacement. So it will start with a top line and we'll see, is there an A in this string? And if there is, it will change that A for a B in this with this line of code. And then it will go from the top again, and it will see, is there an A in this string? In this scenario, the A would be a B, so there wouldn't be any A's. Then it would check the next one, is there an A, two A's in a row, and that would change it to an A. And if there was, that would be an A, and it would redo. And if there wasn't, like here, it would just end the script and return the output or the string we currently have, so which would be BBBCCC. Okay, now we've gotten that out of the way. That's the gist of it. So for this puzzle, we'll have an input, a string of A, B, and C, and we want the output to return true if C is more than B and B is more than A. Otherwise, return false. Okay, how would you do that? I wonder. How would you do that? What I feel like you want to do is. What I feel like you want to do is. You want to take A's against C's. You probably want to sort it alphabetically. And we have a way to do that. We can do BA is equal to AB. We've done this before. CB is equal to BC. And then CA is equal to AC. And this will just take every orientation of letters in wrong order and make them right in the end. So this will always sort alphabetically. Then we can do, if we ever have an AB, we will never have a BA when we get there. That will always have been changed into an AB. If we have an AB, we just say that equals B. If we have a BC, we'll say that equals C. And that's the first part of it, so I will simplify it. So here, for a test string here, which is A, B, B, C, 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 it will first sort it alphabetically. It's already sorted, so we don't need to worry about that. Then we'll take the AB, these first two letters here, and it will just remove the first A. Then it will go here and will remove the first B. And that's where the first issue is. Because now it will return, it would take off the second B. Ah. Well, what we can do after the AB is we can check here if do we have an AC. Because if we do, then we had more A's than B's. If we had less A's than B's, then all of the A's would be gone. We do get an issue with this though if we have exactly as many A's as B's. So I wonder, do we actually want to do this? Just say empty string? Perhaps. Because this will, at this point in the test string here, it will remove the AB completely, right? And then we'll see, do we have an AC? No, we have more B's than C's. We don't have an AC. So at this point, we want to do return and then false. Because if we have an AC, if for instance we have this scenario, we remove the AB in the middle here, we end up with an AC, or more A's than B's. Then we want to be false, because we don't have more B's than A's. But in this test scenario, we do this. Then we want to remove the BC. And at this point, I guess what we can say is, well, we have an issue now. Because what I was about to say is we can say if we have a C, then we can just return true. Because we would have more C's than B's, right? And that's kind of true. I'll get back to that later. Otherwise, we just return false. So it is true that if we have BCC, it will remove the BC. And if we have just a C here, we have more C's than B's, which is true. We return to true. But we do have an issue, and that is if we have a lot of A's and B's and not that many C's. Take this scenario for example. We obviously have more B's than A's, but we have fewer C's than B's, so we want to return false. We can do one more C for this example. It's still true, we have more B's than C's, so they should return false. But what happens if we roll through the script? So we do AB, we delete those, and we do AB and delete those. Now we don't have an AC, so we go further here, we delete the BC. But now look, we don't have a BC, so we go here, we have a C, return true. But that's not true. It should be false. So. How do you stop this? How do you prevent this issue? How do you prevent this issue? I mean, we could use another letter. We could say that AB, that equals D, and eventually that will be converted back to a B. For instance. But what you need to be wary of here is that you need the DB. Or yeah, if you ever change an AB to a D, you need to sort that so you have BD instead. You need D's at the end, and that's because if we have, say we have two A's and two B's, then we take the AB, replace that with a D in the middle there. Now we still have an A and a B that we want to compare, but they are not adjacent to each other, so the AB equals D wouldn't trigger. By sorting these with this script, we we can have a look at this. We can compare these. Now, what we want to say is if we ever have an AD, we return false. Because that will mean we have, for instance, AABCC. We remove the AB, change that for a D. But now we have no DBs to sort here, so we go to the next line, AD. We don't have AD, we have more A's than we have B's. So that's false. But if it passes through this, we can say that the D's will equal B. They will go back to being B's. So here, this B will be like if we have 1, 2, 3, like the original test here, we change this for a D. Then we would sort this to a BD. Then the D would be converted back to a B, so we could do some math here again. And the reason we need to convert to a D is because if we convert to empty, we saw the issue there. But if we just convert the AB to a B, we remove these two, we add a B, right? And we remove this to another B. So this is just removing A's until there are none left. There will never be any left if we just do AB equals B. So that's no good. But I think this is good. We don't need to do the same thing with C's. They are easier. Because that's the end of the string. We have nothing else to compare the C's to anyways. So this should work, I think. No. And the reason why is because there are no B's in this string. So we'll never have an AD situation. So we need a separate instance of if we ever have an AC return false. And that's to catch the cases where we don't have a B in the puzzle. That makes sense. What happened here? What happened here indeed? So do BBCCAAC. BBCCAAC. And we do step through that. We convert the A's. We sort it, right? And this does get sorted. Yeah, that's sorted. And now we remove the A there. We remove that. And we end up with DDCCC. The issue is that we had equally as many. Uh-huh. So, what we want is to check whether we have a B or not. And if we don't have a B, we just return false. But how do you do that? I wonder. How do you do that? If you don't have a B, return false. Good question. Because it's easy to do if we have a B, it's easy to compare. Because we could just look for a B in the string, but now we can't look for a B in the string. You know? So, huh. What we could do during all of this is we could we could hmm, we want to check the first letter if that's a B essentially. And how do we do that? I wonder. If we have exactly as many A's and B's, we get an issue. We do. If we have no B's at this point, after line 7 or before line 8, if we have no B's, it should return false. Huh. What we could do is I wonder if it would help to add another letter here. Like if we did DE instead of AB. Then we could do DEB here, like so. I wonder if that helps. This is still sorted in the same way. We've just written DE instead, but it will always be DE exactly as written in that order. It would never be ED. So you can still sort it in this way, and that will be good. And what we want to do, why would we want this? Well, if we have what we want to end up with is not having this doesn't help. We want to check for not it would be so nice if we just have a not. If we could just do not, we cannot do not. And I'm too much of an idiot to understand what we have to do exactly here. I'm just stupid. Dumb, dumb, dumb. We need to remove this E as well. Oh, I mean, what we could do is we could do a resort afterwards. So after all of this, we can actually sort. We could do BD. We're always gonna have B's and D's in this order because of this sorting. So we can sort this back to being DB. And the reason we want to do that is because we can now check if we have D and C adjacent. Because if we do, we want to return false. Uh, return false. If we have a DC next to each other after sorting into DB, that means we had exactly as many A's and B's because we would have no more B's left in the current string, right? So we would never use this sort and we would end up with a DC scenario. So this should work. Come on. Hmm. This should work, but it doesn't. Why is that? I wonder. Why do we have just a BC here? Oh yeah, of course BC equals blank. That makes sense. Let's do ABB and just do a step by step. What does it do? I perpetually sorts them, of course. An infinite loop. That makes sense. That is not good. That is not good. That is very much not good. I mean, what you can do is you need to change this up somehow. So you can change these into being e's, and then you can just change the d's in these strings to being e's. Then you could change the e's back into being b's. And the reason is we do the same exact thing, really. We need to change u into being an e as well. We do the exact same thing as before, really. The only difference is that this will never go back here and sort because the d's are changed out for being e's. So it will never be db again. This time it works. But there has to be a way to do this with fewer lines, right? Oh, of course we get an issue with the single C. Of course we do. Which which makes sense that we have that. But how do we check for these scenarios? How do we check for these scenarios? If we ever have B and C, these things should work out, right? Because of this line, we wouldn't end up with a C. If we had an A and C, would that work? We have the AC to check. So all we really need to do is check for the single C case. That's the only case that could mess up, I think. We just check for that up top here. If we ever have just a C, that's a fringe scenario. We just instantly return false. Because that's before we do any sanitizing or whatever. Oh, it has to be just a C though. Oh, man. Maybe you do need to change some letters down at the C here. Huh. Because if you just reuse the entire script here, Yeah, because what you want is to say BC is equal to some letter F. Then you want to check, you want to sort. So if you have a BF, that will be equal to FB, and then you keep doing this until you have no more BCs, they're all Fs. And then if you have an FB, you return false. And only if you have an FC can you return true. If you have a FB, return false. And only if you have an FC can you return true. Is that accurate? I don't even know what I did. I just pulled it out of my booty, Just made it up on the spot. It seems to be working on all fringe scenarios. At most 8 lines. Are you actually insane? I'm not doing that quite yet. I think there's gonna be more keywords that we get to learn in the start end that allows us to check the first and the final letters. And I think we need to get more keywords first. I bet you we can go back and do them with these. So let's just learn more of the game first. 2-8 most. A string of A, B, and C, that's the input. Output return the most common letter. There's no ties for the most. Okay. Well, what you want to do is you want to remove one of each letter at the start. Then you want to remove one of the two most common letters, or the two remaining letters. Or if you remove one of each letter in the start and the two tied for the least, because they're never tied for the most. If the two tied for the least seem to have an equal number, you will just end up with one letter anyways at the end. So what you want to do here is, it will be very neat to sort it like in ABCs somehow. So ABC, ABC, AB, like so. So you had different letters adjacent, never the same. That doesn't seem to be easy to me to do. So what you probably want to do here is, you probably want to, first of all, I think you want to sort this alphabetically. So if we do this again, now we have them sorted alphabetically. I think what you want to do is use additional letters. So you want to say something like AA will be equal to AD. BB is equal to BE. No, we want that to be BD, don't you? No, that won't work. I want CC to be equal to CF. And, well, see what you can do with this. Because you can get adjacent D, E's, and F's, and you can do it without that many lines of code. So if you do instead FC here, now F will not be sorted in this algorithm because we don't have F's here. Then we could do BE. So now we'll always have E's and F's adjacent, right? After all of this converting, you'll be stuck with at most one of each letter. Then what you want to do is you want to sort it so that the D's are next to E's, and the way you do that is by saying DB is equal to BD. And that will just, if we have AD, BE, FC, okay, I will show that down here. So say I have input string AABBCC, then, since we need the most of one letter. AA will be converted to AD, BB converted to BE, and then this first pair of CCs will be converted to FC like so, and this second pair will be converted like so. Then the D and the B here that would equal BD, like so. And now you have D, E, and F adjacent to each other. Okay. Why do you want to be down there? That's gotta be a bug, right? You're not supposed to be all the way down there. Oh, this is making it hard to work with. Why are you doing this to me? Come on. Well, let's just do Control A, Control C. Let's go out. Let's try again. Oh, and now it works. Okay, cool. Well, sort these, and you have D, E, and F adjacent. Now, you could end up with a scenario. We will want one more F here, actually, because the CC will be FC. We could have a scenario where you have EE, which does make things a little bit tougher. And what you can do here to avoid that is by saying, if you ever have an EEF, that will just be equal to EFE, right? So in this scenario here, we have an EEF. This F, this E would just be moved to the other side of the F. And if we had another EF here, that would be moved here. And then that would be moved here. Okay. So what we have now is a DEF. And if we have a DEF, we can just delete all of them. And the idea is that at this point, like the DEF are just stand-ins for A's, B's, and C's. So you remove one of each letter. Say you have two A's and two B's and three C's. Remove one of each. You have one A, one B, and one or two C's. You still have the most C's, right? And that's what we want to do. So we want to simplify it down to be a string of fewer characters. So you do this to keep the thing we care about in the original string intact, which is the frequency of each letter. We keep that intact. Really? So we would delete the DEF if we have a DEF. And now we have a string looking like this. We can now check if we have any more DEFs, they will also get deleted. And they will be properly sorted at this point in time. Because all of the Ds will always be after the B's, but before the E's start. And if we ever have two E's, they will be moved to the other side of the F, right? And if we have multiple F's, we'd have EF, EF, EF. So we could just remove def, def, until it's looking like this. At this point, we want to check for scenarios where we only have two of the remaining letters. If we're all out of defs, right? And that would mean that we are out of one character entirely. Now, which character would that be necessarily? We don't know. And that's kind of important to know before we do any further editing here. So, would be so nice if we could just do if DE and then something, but we can't do that. If we have a DE, we know that the F is standing for C. We know we have the few C's, we can just remove those. But that doesn't work. So if we don't have any defs left, we need to check, do we have any Fs left? And if not, we remove all of the C's. How would we do that? Do we have any Fs left? Well, what we want to do is, if we have a DE, we know that we have no Fs left, because the F would always be after the E in the DE here. And that's probably the scenario we really care about. We don't actually need to look for C's anymore because we're out of F's. So we know we have diffused C's. We can say that DE is equal to nothing. Can say that. I think we can. Because remove these. And we would never have equal amounts of D's and E's in this scenario. Say we have one more E. And we remove this and we're only stuck with an E, which means E isn't stand-in for B. We would have the most B's. Now, at this point, we also want to check, do we have any EFs? If we do, destroy all of those. Also check, do we have any DFs, in case we have no more E's? And if we do, destroy those. Afterwards, after all is said and done, D equals return A. Because if we still have a D after checking for all possible configurations of two letters here and destroying all of them, we know that A is the most common letter. E, return B. Same reason. If we have an E after destroying all letters like that, that must mean that we have the most B's. And then F is the stand-in for C. And I'm curious, does this work? Probably not. No. Strange. Because this converts it to a step-by-step on A, B, B, C. Was it like so? I think. A step-on-step for that. Yeah, of course. So we should have the most B's, but we remove two B's. Two. Oh yeah, because we remove them twice. Once with the E's and once with the A's. Hmm. This complicates things. That complicates things. I do like the whole def situation of having those adjacent to each other. Like, it would be so nice if we just had a not. Oh, I would check if we had nothing of an E or a B, whatever. Oh, I'm struggling. I'm struggling so hard. I cannot figure this out. This is too difficult for me. Far too difficult. I feel like we're so close, but we need to get rid of that original. Well, actually, after sorting, is there anything wrong with just saying individual letters, so changing them completely? Uh, like so? That seems to work. Of course, because then we're not stuck with original ABC. I must be honest, I don't get why the DEEFDF doesn't break it. I feel like it should, but it doesn't. We can still remove 4 lines from this. Honestly, 4 lines is a very strange number. 4 lines is a very strange number to me, because they're all in chunks of 3. Could you possibly? Could you possibly do that? I guess why it works is the original reasoning here is that def there will only be 2 letters left after removing all instances of def. So the 2 letter thing doesn't break when we change all of the letters here. Because we'll only have 2 letters left at this point when we get there, anyways. Now, what I'm curious about is how the heck do you remove lines here? Well, you don't need the DB anymore, that's for sure. You can remove that. This should still work, right? Don't see why it wouldn't. At this point, you can remove 3. And I feel like I feel like there's something here. You need the A equals D, the B equals E, the C equals F necessarily. Because I'm not convinced you do. I'm not convinced you do. Also, worth noting, you don't necessarily need the return A. You could just convert these E's and F's back into A, B's, and C's and remove duplicates. I know that would take more lines here, but it might be useful knowledge that you don't need the return. Like, have that in the back of our minds. I feel like it's so tough to do this without converting because you can't sort it like this then and use all of this really because it would convert back to this two letter sorting. Well, what you could do is after sorting, could you not convert? Well, it would require even more sorting, so I don't see. Let's have a look at it. I don't see how it would work because it requires more sorting. I think that would take more lines of code. But I do think that you can say after sorting that AB equals D. And then you need to sort so that you still have the A's and the B's next to each other. So you need to do DB will be BD. And this will convert all instances of AB into a D. And what you can do now is you can convert the D back into either A or B, depending on which one is still left, if any. So, we could do A, D is equal to A, and D, wait, yeah, and BD is equal to B. But also, after this, you can do DC is equal to return C. And the reason you can do this is because if you have a DC after converting all instances of either AD to A or BD to B, that just means you have no A's or B's left. So C has to be the most since there are no ties for the most. Now, do you necessarily need to do this? Probably not. And it might honestly be easier to just say that D equals nothing at this point. Same reasoning really, but we will return down here instead, so we don't need... We just lose an extra line of code here for nothing, I guess. We get rid of the D's to make comparisons easier down here. So you have this, and you now have checked what you have the most of when it comes to A's and B's. After which, you could compare A's and C's and just say that that's an empty letter. And the same for B and C, say that's an empty letter. And when you're done, you're gonna have one letter. That could be B's, that could be A's, that could be C's. And the only issue is that you can have multiples. And you don't want multiples. It's so close to working, because at this point, we could almost send it, but we need 3 more lines of code. And that's AA equals A, BB equals B, and CC equals C, to get rid of all duplicates. At this point, you will only have 1 letter left. And of course, this doesn't work, because the game is actually trolling me. This is ridiculous. Why wouldn't A, B, B, C, B, C, A work? A, B, B, C, B, C, A. That was the line, right? Hmm. That's strange. Try that again for me. So, it converts the A and B to D. Oh. Was it test case 7? Yeah, I think it was. So first it sorts, which is fine, we want that. Then converts the A's and the B's into DB. But it does not convert back. Oh, because, oh, of course, BD needs to be BB. AD needs to be AA. That's what it was supposed to be here. That's why it doesn't work. Now it should work. And it does. We can still get rid of 2 lines. How would you get rid of 2 lines here? You know, I think it's something to do here. Probably. Do you need to convert the AD back into AA, the BD back into BB? I mean, you gotta, right? Because if you don't, You can compare these to C's, but first of all, we might have more A's or more B's, and we need to compare those as well. Well, you can do that, can't you? You can say DC is equal to nothing, and then AC and BC is equal to nothing. And this will still compare the D's, which will be A or B, it can be any one of them, we don't really care. And then we'll convert A's or B's if we have any more, which will be the one we have the most of. So it will do, like, say we have 3 A's and 4 B's. We'll end up with having 1 B and 3 D's after the conversion to these. And then it will just see that we have 1 B left, and we'll compare that. So that's kind of working. We don't need to remove these at all there. You can say DC is blank, like so. We still need to remove 2 lines though. But that's these. And this is so close to working now. We're at the perfect amount of lines. But we do have an issue, and that is AD and DB. So we might, you know what we can do? After doing all of this, we can see what letter remains. And we can do this. If we have an A at this point in time, we can just return A. If we have a B at this point in time, we can just return B. If we have a C at this point in time, we can just return C. Does this work? I cannot believe it. What we do is we sort alphabetically, then we convert A and B to D, which is a stand-in for, ends up being a stand-in for what we have the most of. Like, if we have the most A's, D will equal A later in the script. If we have the most B's, D will equal B. DB is just to sort, so we can keep doing the AB situation. DC will remove all the D's. Because of the sorting, the D's will always be next to the C's, if any C's. Afterwards, if we have any A's or B's, that might be the letter we have the most of, right? And we will only have A's or B's now, because of the whole AB thing. We'll never have both. So we either have zero of both, which means this will remove all of the D's too, and we can go here and return C in the end, because there are no other letters. Or we'll have A or B. No more D's at this point in time, or there could be D's if there are fewer C's than D's, which is fine. But anyways, we'll only have one of these. So if we don't have the most C's, like, it will just check what letter it is from the original check here, checking what letter we have the most of. Brilliant. Absolutely brilliant. I feel like this game is really breaking my brain here. I don't know if I can go anymore. Really, I'm struggling so much, dude. But yeah, that's all the time I have for this episode by far. Thank you guys so much for watching this. I do hope you enjoyed, and I hope we'll see you next one. And remember, if you want to become a flopper just like us, do consider hitting that subscribe button. It's free, and it really helps me out. Anyways, have a nice day, and goodbye!